Hello and welcome to this lecture on index numbers, a powerful statistical tool used to measure changes over time in economic data like prices, quantities, and values. Whether you're a student preparing for an exam or someone curious about how we track inflation, GDP changes, or cost of living, this video is for you. So in this lecture, we will cover what index numbers are, the types of index numbers. That's we're going to look at the price index numbers, the quantity index numbers, and the value index numbers. We will also look at the characteristics of index numbers, some uses of index numbers, problems of constructing index numbers, then chain-based index numbers. Thus, given a fixed base, how do you convert it to a chain base? And also given a chain base, how do you convert it to fixed base? We would be looking at base shifting, splicing and deflating, consumer price index or the cost of living index, deflated sales, how to compute for your real income given your nominal income. Then we look at purchasing power of money. Purchasing power of money. We would also be solving some practical examples step by step. So grab your calculator and let's dive into it. So what is index numbers? We know that most values change, and therefore may want to know how much change has taken place over a period of time. For example, we may want to know how much the price of different essential items to a household have increased or decreased so that necessary adjustment can be made in the monthly budget. In an organization, one may be concerned with the way in which prices paid for raw materials, annual income and profit or commodity prices, or share prices, production volume, advertising budget or wage bills, and so on have changed over a period of time. However, while prices of few items may have increased, others may have decreased over a given period of time. Consequently, in all such situations, an average measure needs to be defined to compare such differences from one time period to another. So index numbers provide a yardstick for such difference. So now what is index numbers? So index numbers can be defined as a relative measure. So it's a relative measure describing the average changes in any quantity over time. In other words, an index number measures the changing value of prices, quantities, or values over a period of time in relation to its value at some first point in time called the base period. This resulting ratio of the current value to a base value is then multiplied by 100 to express the index as a percentage. Since an index number is constructed as a ratio of a measure taken during one time period to that same measure taken during another time period called the base period, it has no unit and always expressed as a percentage term as follows. So index number is given by your current period value divided by the base year value times 100. So basically what the index number is trying to tell us is we are trying to look at the relative changes of the same item over a given period of time. Assuming we want to compare the prices of a laptop in these two periods, let's say in 2020 and 2024. So we are going to take the prices of this current period, then divide by the price of the laptop in 2020, then multiply the what? The answer by 100. Whatever you get. And since index number is being compared to what? A reference period. That's a base year period. It has an index number of what? 100. So if you get anything above what? 100, anything above 100, then we can say that prices in 2024 were higher as compared to what? That in 2020. Likewise, if you get anything below 100, you can say that prices in 2004 were lower than that of 2002. Also, we can also convert numbers, or you can also compute changes in a percentage change in what? In a quantity or in a economic variable to what? To index numbers. What I mean is, assuming um, you've been given a price. So in 2020, the price of a laptop was, let's say, 40, let's say $40. Then in 2024, price rose to $100. So now what is the percentage change? So now the percentage change in the price of this laptop is 100 minus 40 divided by 40 times 100. So now we have 60 divided by 40 times 100, giving us an answer of 150. So meaning that over between these two periods, that's 2020 and 2024, there was a price change of what? 150. And since always the base period, let's assume that 2020 is the base period. And since the base period is 140, we can what? Add this 150 to the what? 100. Then we can say that the price index of laptop for 2024 was 250%. The meaning that price increased by 150%. Okay, now let's look at types of index numbers. Basically, we are going to look at three. That's the price index numbers, the quantity index numbers, and the value index numbers. So as the name suggests, price, you are dealing with prices. So you're looking at the relative changes in price of a commodity between two periods. It is basically the ratio of the price of a certain number of commodities in the present year as against the base year. So if you are being asked to find the price index between two periods, so price index is basically the what? The current period price divided by the what? The base year price times 100. We are going to explore more to find the sample price, the sample quantity, and the what? Sample value. Then when it comes to the quantity index, so as the price index dealt with prices, quantity, we are dealing with what? Quantities. It measures the changes in the physical quantity of goods produced, consumed, or sold of an item or group of items from one period to another. It's also given by the current period quantity value divided by the base year quantity. Then when it comes to the value too, the value is basically the multiplication of the price and the quantity. But to get a value, the value is basically the price times what? Quantity. This gives you what? The value. So when you transfer the same knowledge to index numbers, it's basically what? The current year or the current period value, which is the price times quantity for both the current period divided by the base year what value, which is also the price times the quantity. Then you multiply the answer by 100. This pertains to compare changes in the monetary value of import, can measure the monetary value of import, the changes export, production, or consumption of commodities. It has limited use as it cannot distinguish between the effects of prices and quantities separately. So basically, when you use a value index, because it combines both the price and the quantity, we can't really determine which one has caused it to increase or decrease, whether the price or the quantity. Okay, now let's break the price index. The price index, we have the simple index. So with a simple index is also called what? Unweighted. We are going to look at the simple price, the simple quantity, and the simple value index. For the simple price index, it's a single unweighted price index number. Measures the what? It measures the percentage change in the price of a single item or a basket of items between two time periods. For quantity, it's also unweighted quantity index numbers. It measures the percentage change in a quantity for a single item between two time periods. Then for value, as the name suggests, is the price times quantity. It measures the value for a single time period with respect to base time period. Then we have the aggregate. Aggregate. So aggregate, we are going to look at the aggregate price index, the aggregate quantity, and the aggregate value. Aggregate means summation. So we would solve an illustration to clear you on the aggregate index. Then for the weighted, we also have the last price index. For the last price index, we are going to explore the last price price and the last price quantity. Then for partial to partial price and partial quantity. Then lastly, Fisher's ideal index. So Fisher's ideal index is basically the geometric mean of both the last price and the partial index. We're also going to look at in terms of the price and the quantity. We have a whole lot of the weighted, we have the Marshall Edgeworth, we have there are a lot, there are a lot over there. But our main focus will be on these three. Our main focus will be on this three. So let's take some illustration on just the simple price index. Then in another video, we will look at some illustration on the aggregate and lastly, the weighted. The retail price of a typical commodity over a given 5 years is given below. So we are to use 2015 as the base year. So now we have to compute for the what? The simple price index. The simple price index. How do you find the simple price index? So simple price index is given by, we have the current year price over the base year price times 100. Okay, and since 2015 is the base, always take note that the base year is always 100. The base year, which is the reference period, is always what? 100. Can, if you also want to solve for 2015, so let's say simple, here's the simple price index. So for 2015, we have a value of 10 divided by the same 10 times 100, giving us 100. So for 2015, the simple price index is 100. Then 2016 also, for the simple price index given by the current price index, as in the current price in 2016, which is 12, divided by the price of the base year, which is 10, times 100, also giving us a value of 120. So for 2016, the simple price index is 120. Then for 2017, we have a current price of 15 divided by the base year price, which is 10, times 100, also giving us a value of 150. In 2018, we also have a price of 11 divided by 10 times 100. 110. Then for 2019, its price 9 divided by the base year price 10 times the 100 is giving us 90. Okay, so now how are we going to interpret this price index with respect to the reference period? That's the base year. So if you are from 2016, if you are to use 2016 and 2015, you can see that price rose by 20%. Price rose by 20%. Then for 2017, so 2017 and 2015, you can also see that price rose by 50%. Then for 2018, by 10%. But when you get to 2019, we are having what? 90, meaning that there was a decrease in price by 10%. So this is how we interpret the index numbers. We compare it with base period. All right, now let's come to the simple quantity index. Simple quantity index. Okay, for simple quantity index, the same idea as the one we just solved. So simple quantity index, simple quantity index is also given by the current year or the current period quantity divided by the base year quantity times 100. So now let me create another column for the simple quantity index. The simple quantity index. So now for 2015, we have a value of 200 divided by 200. Since 2015 is the base year, automatically it's going to be 100 times 100, giving us 100. And 2016, we have 240. But always bear in mind that irrespective of whichever year we use as the base year, we are going to get 100. That's one thing you should keep in mind. So 240 divided by 200 times 100, 120. 2016, we have 120, a simple quantity index of 120. Then 2017, 300 divided by 200 times 100. Also giving us 150. Then for 2018, we have a quantity of 180 divided by the base year quantity 200 times 100. Giving us a value of 90. And lastly, for 2019, a value of 250 divided by 200 times 100. One two five. So how would you interpret this? The simple quantity index we got. So pause the video and try to interpret it yourself. Okay, so you can see that for 2015 and 2016, our quantity index increased by 20%. Can say that there was an increase in quantity in 2016 by 20%. Then for 2017, we are comparing to the base period, which is 100. Also, there was an increase of 50%. Then for 2018, 90, which is below 100. So it was a decrease in quantity by 10%. Then lastly, for 2019, we have an increase of 25%. We have an increase of 25%. Okay, now let's solve the last one. That's on the simple value index. So simple value index. Simple value index value index value is basically price times quantity. So if you have the same knowledge in index numbers, is current year or current period value, which is price times quantity, divided by the base year value, which is also price times quantity times 100. So now let's find the value. Let me create another column for value here, which is basically a price times a quantity before we find the index. So it's given by the simple value index given by the current year value divided by the base year value times 100. Okay, so now let's find our value. How do you find the value? The value is the price times the quantity. So we have price here and quantity here. So 10 times 200. We have 2000. Then we have 12 times 240. 2880. 15 times 300. 4500. 11 times 180. 1980. Then lastly 9 times 250. 2250. So now we have our value. You can go ahead to find our simple value index. So simple value index for 2015. We're also assuming that 2015 is the base year. So this is the base year. If this is the base year, then automatically we are going to have 100 here. Because since we are going to get the 2000 for 2015. So 2000, that's the value, divided by the base year 2000 times 100, giving us 100. Now 2016. 2016 is given by the value for 2016, 2880, divided by 2000 times 100. So 2880 divided by 2000 times 100 is giving us 144. 144 for 2017. We have a value of 4500 divided by 2000 times 100, giving us 225. 225. 2018. 1980 divided by the base period value 1980 divided by 2000 is giving us 99. 99. Then for 2019 we have a value of 2250 divided by 2000 times 100. 112.5. So now this is a simple value index. So you can see that for 2016 as compared to relative to 2015, the value increased by 44%, and 2017 and 2015 we have an increase of 125. Then for 2018 a decrease of 1%, and lastly 2019 an increase of 12.5%. Okay, so all the simple indexes can also be called the relative index, and the aggregates too we can also call them the composite or the composite index. Okay, so now we are done with the simple or the relative index. If you have any question, you can put it in the comment section. In our next video, we will look at the aggregate index. then weighted index. Thank you.